we just did it as a pop quiz. Pop quiz number 2. So the first one, maybe you had to look it up. Maybe you were looking at the information that I put on the board. You try it now. We remember more of what we quiz ourselves on than what we copy. And if you want to continue the pop quiz, scroll down. These are our Pythagorean identities. So the Pythagorean identities are written out for you down here, but in this section you can do your pop quiz. What is it? Okay. So now you've got those recorded. Let's try it. So this is what's going to happen. You actually have enough information that you guys could totally do this on your own. I'm going to show you 1, and then I'm going to have you guys try 2 and 3. Okay, so here's the idea. And the general strategy. There's a few different strategies, but the general strategy that people have is to turn everything into sine and cosine. If you make everything sine and cosine, all the sines and cosines tend to cancel out or simplify in one way or another. And then if you still have sine and cosine at the end, you can turn it into a tangent or a cosecant depending on what you have left. So that's our basic strategy, right? So I'm going to replace tangent with sine over cosine. And cosine of theta is over 1. And now I just have a simple fraction problem. Cosine over cosine cancels, and this equals sine of theta. So even though I said these are kind of like proofs, they're like proofs because you have to use these theorems to move from one step to the next. But they're also kind of like algebra problems where like you're solving an equation and you do one step each next time you go to the next to simplify it or to like figure out what the next final value is going to be. Okay, you guys try 2 and 3 with your teammates. I'm going to blank my screen, see if you can get it down to one single trig function. Come on, screen. So get it all the way down until you have one trig function left. So for those of us that struggled with complex fractions, there's a lot of complex fractions in these. So let's take a look. How'd we do? Did anybody get a little screwed up on number 3? Okay, so here are my suggestions. Number 1, write very neatly. Maybe smaller than you're used to writing. Keep things on lines. Do not use slashy fractions. You want to do sine over cosine. That's never going to work out for you. You're going to get lost and lose your place. Make sure that you are very organized and neat. Also, you are allowed to rewrite division in this format. And for a lot of people, that makes it a lot clearer to see what the next step is. And I didn't show it, but there's actually another step. I could have rewritten the division as multiplication by the reciprocal, cosine over sine, and that would have helped to make a lot of sense too. This is not the only correct way to do the problem. Did anybody rewrite 1 over tangent as cotangent? You could have thought about it this way. I'm going to use a different color. So you could have left sine secant times 1 over tangent and rewritten tangent. So sine of theta, 1 over cosine of theta, and tangent is cotangent of theta. And then you have sine over cosine, tangent times cotangent equals 1. The trouble with these problems is that there's almost always more than one correct way to process through them and see how they work. Here's the next thing. Did I make an equal sign daisy chain all the way across my page? I did not. I show my work going down. So when you do a proof, you would show the next step underneath, the next step underneath, the next step underneath. And I don't split off any little bits and like process this little piece all by itself. I want to make sure that this is equal to this, is equal to this, is equal to this, going down my page. The reason for this is that next year when you're in honors pre-calc, you're going to have what are called proofs that are identities, and it's going to tell you this equals cotangent of theta, and you're going to have to write it out as a proof. The rule for a proof is you can only work the one side. You cannot work your conclusion. So you'll have to think about it going down the page just like this. So you want to get into a habit of doing that right now. It'll make it easier for next year. Questions? Okay. 5. Oh my God, these are awesome and I want to do like a million more. Fist. I want to punch this problem in the face. How are you feeling about these? 5, 4, 3, 2, 1. Who's got a fist? Who wants to punch a problem? Where's your hand? There it is. Okay. Yusuf, how are you feeling? I can't see your hand. We got a 3. Okay. Some 2s and 3. Okay. All right. Let's see if we can all get up to a 5. I like these, but I'm a weirdo, so that's fine. If you didn't already fill in this Pythagorean identity stuff, here it is. These two are super useful, but again, you don't need to memorize them. So if you know that sine squared equals 1 minus cosine squared, that saves you a lot of time and energy. If you forget, you can always go back to this and subtract cosine, right? So you don't really have to have it, quote unquote, memorized, but it is something that shows up a lot and you can use it. And then the last part, the 1 plus cotangent squared, that's what we did on the back board over here. If you wanted to record what's back here, or even like take a picture and paste it in, feel free. Because those two, again, you don't have to have it memorized if you know how to get there on your own. So these are the Pythagorean identities. And you could find any combination of these. You could find that 1 equals secant squared minus tangent squared and have to make that substitution. You might have to substitute for cotangent, so you do cosecant squared minus 1. So depending on what you have in your problem, you might need to solve these for one bit or another. Pay attention to the square. The Pythagorean identities only work when a side is being squared. Okay, so let's use this one. So 1 minus cosine squared equals sine squared. And we are allowed to know that. I don't have to show any work for that. I can just have that memorized. So I can, in one step, replace this sine squared theta divided by cosine squared theta. I'm going to show a middle step, but again, you could probably skip this. Sine over cosine squared is going to be the same as saying cotangent squared theta. No, I did that backwards. Tangent. It's tangent, not cotangent. Oh my God, you guys. My brain stopped working. I'm back. It's fine. Questions about that? Okay, so try these. These are complex fractions, no calculator. Just to practice working with how fractions work. Oh, I'm changing this. We're going to change this one. This one is going to say 1/2 plus 1 over 2. So try these 4 with your teammates just to practice doing complex fractions. Sometimes it's easier to remember the fraction rules separate from the sines and cosines. And then we'll get back to the sines and cosines and hopefully you won't cry. As you're doing these, you might start seeing some shortcuts. So more important to me than you guys getting the correct answers would be learning these shortcuts that'll help you with other stuff. Okay, let's take a look. So the first one I did kind of step by step, really slowly. I did 2/3 divided by 4/15, and then I rewrote it, and then I did the multiplication by the reciprocal, and I actually canceled. So I did 2 divided by 2 is 1, 4 divided by 2 is 2. 15 divided by 3 is 5. 3 divided by 3 is 1. And I got 5 over 2. But I want to show you a shortcut. One of the things you can do with complex fractions is you can multiply the top and bottom by the GCF. Times 15 over 15. What's 2/3 of 15? 10 over 4, which equals 5 over 2. Some people like that better. It makes more sense to them. Again, multiple ways to get to the right answer. That's always going to be the problem with this section. Here's number 6. So for this one, I rewrote it as multiplication by the reciprocal. I kind of skipped the middle step. And then I was able to simplify really quickly. 4 over 4 cancels. 35 over 5 is 7. Always get smaller before you get bigger. You should not be doing 4 times 35 divided by 20. You should be simplifying before you multiply. Okay? For this one, I noticed that the denominators were the same. So 2 times 1/5. I'm just showing this I'm showing this so you can understand. I would never really write this out as a problem this way. But 1/5 and 1/5 cancels. And I can skip straight to the answer, 2/3. 2 divided by 5 is 2 times 1/5. So if I can pull that out, that denominator cancels. And I just have the 2/3. And then here's this one. This is not the only correct way to do this, but this is my favorite way. The LCD, the least common denominator for all the teeny tiny fractions inside that fraction, is 2. 1/2 times 2 is 1, plus 1 times 2 is 2. And in the denominator, 2 times 2 is 4, so your answer is 3/4. If you don't like that, you can do it this way. 1/2 plus 1 is 3/2 divided by 2. 3/2 divided by 2 is the same as 3/2 times the reciprocal 1/2, which equals 3/4. In my mind, it doesn't really matter which method you use as long as you get to the same correct answer, but I want to give you a couple different choices for how you think about it to make it easier for you as you do these problems. Questions about any of that stuff? Okay, so get ready. Now we're doing it with sine and cosine. Dun, dun, dun. Here we go. We have cosecant divided by cotangent. Our number one strategy is to rewrite everything as sine and cosine. So I am going to take cosecant and write it as 1 over sine. Big division. I'm going to rewrite cotangent as cosine over sine. Oh, it's x. Sorry. I can rewrite my division as multiplication by the reciprocal. 1 over sine x times sine x over cosine x. Sine over sine cancels. 1 over cosine x is secant x. How you feeling?
In the denominator on the top, did you mean to put sine x over cosine?
Cotangent is cosine over sine, right?
So why does it flip the next?
So cosine over sine is cotangent. I skipped a step. Here's the extra step. 1 over sine x divided by cosine over sine. Then it rewrites as multiplication by the reciprocal. That's why. And I don't mind if you skip that step, and I don't mind if you write that step. Both of those are fine for me. Did anybody feel like they needed to skip this and go from here to here? Did you see it? The sine x in the denominator cancels. It's like canceling a common factor. I'm actually okay if you skip from here to here. I'm not okay if you skip from here to the answer. And if I'm telling you that it's a proof, the more steps you show, the better. In terms of, like, a proof is basically explaining your thought process to another human being. So the more steps you show, the more they understand. So I would put an extra. Okay, next one. So 1 minus cosine squared. You are allowed to know, and I'm going to put a little asterisk, 1 minus cosine squared equals sine squared. Oops. I got to do theta. I don't know who did x. They should be thetas. I don't like the x's. But I'm allowed to know that. I'm allowed to have that memorized. So I can just switch to sine squared x over tangent squared x. And now I've got sine squared x divided by, tangent is sine over cosine. I'm going to rewrite this as multiplication by the reciprocal. So times cosine squared over sine squared. The sine squareds cancel, and I'm left with just cosine squared x. Again, not the only technique. You might have changed it to be sine squared times cotangent, and that would have skipped you down to this step. How are we feeling? Okay. You try number 11 then without me. Give that one a whirl. See if you can get it. Fun fact, you're allowed to know that cosine times secant equals 1, so you could have skipped the first step. I tend to write more steps rather than less steps because it's less confusing, it's easier to follow, but you're allowed to skip. How do you feel? When does this bell ring? Today's Tuesday. 4 minutes, okay. 4 minutes to do these last 3 problems. Here we go. Sine over cosecant. So we have sine over 1 over sine, or sine times the reciprocal sine. So this one is sine squared. Sine squared times cotangent's our next one. So sine squared times cosine over sine. Oops, x, not theta. The sine over sine cancels, and this one we're left with cosine squared. Last one. Tangent times cosecant. So we have sine over cosine times 1 over sine. It's going to give us 1 over cosine. Technically, we only have one trig function, but we always want it to be not a fraction if we can. So 1 over cosine turns into secant. That's the best answer for this one. Okay. 5 These are amazing and I love them. 1, not so much. How are we feeling now? Okay. They get more complicated as we go, but I'm glad that you're enjoying them in the moment. So there's, I don't know if I posted it. There is a worksheet for this. I need to post it on Schoology, so like a worksheet homework. It's not posted? Okay, I will make sure I post it. It's for today and for tomorrow. Today is Tuesday, and then we're reviewing, and our test is on Friday, so this is it. This is the last. There's like notes for tomorrow, but it's more of the same.
I'm not going to be here on Thursday, so it's just reviewing.
We're reviewing for the test.
Do you have any like review sheets I can do?
Not at the moment, but I'll